Today in this video we'll be talking about implicit differentiation. An expression that can be written in the form of y is equals to x squared is said to be an explicit function, and we have already done differentiation of an explicit function. So an expression that can not be written in the form of y is equal to x squared is said to be an implicit expression or an implicit function. So for example, this function here cannot be written in the form of y is equal to x squared. Therefore, for us to differentiate, there are rules we always follow, and the rule is we must always differentiate both sides of the equation with respect to x. The other rule is that expression that involves y, when we differentiate with respect to x, we multiply dy dx. So for us to differentiate this one, we are going to differentiate each term separately. So for us to differentiate y power 4, we find y power 4 will be 4y cube, and then we multiply dy dx plus differentiate x squared, that is 2x, is equal to differentiate x, that is 1, plus differentiate y squared, that is 2y, but we multiply dy dx. From there, we combine expressions that possess dy over dx. So we can see here 4y cube has dy dx, also 2y has dy dx. So we take 2y dy dx to this side. So we are going to have 4y cube dy dx minus 2y dy dx is equal to 1. This positive 2x, we take it to the other side, that will be minus 2x. So from this expression, we can clearly see that whatever is common is dy dx is common for the left hand side of the equation, and we have, if we remove dy dx, we're going to have 4y cube minus 2y, that is the left hand side, is equal to 1 minus 2x. So for us to have dy dx on one side, we divide both sides by 4y cube minus 2y over 4y cube minus 2y, so that this one will cancel, and finally we are going to have our dy dx finally will be 1 minus 2x over 4y cube minus 2y. In the second expression or function, we have x cubic minus xy plus y squared is equal to 2, 4. We do the same, but here there is a bit change, because you can see that there is xy here, which is different from the first function in the first example. So we are going to apply the concept of product rule here. So any expression that has y, when we differentiate, we multiply dy dx. So let's first of all start differentiating x cube, that is, if we differentiate x cube, we get 3x squared, minus, when you come to this one, we use the concept of product rule, u bar v plus v bar u. U bar, we start with u bar. U is x, derivative of x is 1. U bar, v is y, so we multiply y, plus v bar, v is y, when you differentiate y, we get 1, but we multiply x because it is v bar u, and then because we have differentiated a function that contains y, we multiply dy over dx plus y squared, the derivative of y squared is 2y, and then we multiply dy dx, because it's a function that contains y, is equal to the derivative of 4 becomes 0. So we are going to have here 3x squared minus y plus x dy dx plus 2y dy dx is equal to 0. So we combine expressions that have common factor, that is expressions that have dy dx. Now here we forgot that if we multiply -1, negative with 1 we get -1, but if we multiply negative with positive, here we are supposed to be having a negative. So let's take the rest of this equation to the other side, so that we are going to have minus x dy dx plus 2y dy dx. I will remain this on the left hand side because both expressions have dy dx. If I take 3x squared to the other side, this will be negative 3x squared plus y. And here, what's common is dy dx is common, and we have minus x plus 2y is equal to minus 3x squared plus y. So for us to remain dy dx on the left side, we divide negative x plus 2y divide negative x plus 2y. This will cancel. Therefore, the derivative of the function will be dy dx is equal to negative 3x squared plus y over negative x plus 2y.